All right, this is the Algebra 2 Unit 7 study guide, or the review video. I'm going to go over the study guide and answer each of the questions and kind of talk you through what you need to know on the test. So yeah, we're going to jump right in. So first thing here is synthetic division. You should be pretty familiar with this from what we did in the lesson and previously in other units. To write this in synthetic division form, you need your little sideways t-chart. And we are going to have in the top the coefficients of this top, the numerator, 5, -6, 3, and 14. And then outside, we are going to write the 0 of that denominator term, which in this case is going to be -1. Again, I say the 0 because you need to write what makes that 0. So -1 plus 1 is 0. So then -1 is the number that goes outside on synthetic division. Lots of examples on the video, so I'm only going to do this one. But remember, the process is you bring down the first term, and then you multiply the divisor, -1, and write the answer here. So -1 times 5 is -5, which makes -11, times -1 is 11, which makes 14, times -1 makes -14, which cancels out to 0. And so then these become the coefficients of the answer. So the answer is going to be 5x squared minus 11x plus 14. And that would be the final answer there. Remember, that's because the degree of the polynomial decreases by 1 when you do synthetic division. So it goes from 3 to 1 constant to 2, 1 constant. And so that would be your answer there. The next big concept is dealing with changing the parameters of rational functions. Again, the video goes over this pretty extensively. But just remember that I'm going to go through each one of these. Each one of these is an example of one type. The first is an example of a vertical shift. Because this is +6, it's going to shift up 6 units. The second one here is an example of a horizontal shift. This is going to shift left 3 units. Right would be negative. Left is positive. +3 means left. Minus would be to the right. Again, you need to go back and look at this section for help with this. And then lastly, when there's a multiplier or something other than 1 in the top, this is going to stretch by a factor of 4. And that's it. That's what this changing term tells us there. All right. Then there's 2 lines down here that there are not sample questions for. The first is just that you need to be able to identify the graphs of inverse and rational the inverses of rational and radical functions. I would just recommend going back and looking over that information on the videos and on the lessons. Identifying graphs really is just saying they're going to give you an equation and you decide what the graph looks like. And then same thing with this last line is determine if points are part of the solution. So you're going to have a graph and they'll ask you, is this number part of the solution? And you just see if it's either on the line or in the shaded region if it's an inequality. So we went over a lot of those previously. So let's jump to our next set. This is all about restrictions and asymptotes. So when you says find the restrictions on the domain of the function of the rational function, we're talking about the numbers here. So we're going to take these and we're going to write 2 equations. And then we're going to solve those. We're basically finding the roots of the denominator. So we can add 5 to both sides. X equals 5. And actually, it's x does not equal 5. We should say from the beginning these were does not equal because we're asking for the restricted values. And then we subtract 4 from both sides and we get x does not equal -4. And so those would be the two restricted values. So restrictions, again, these are the roots of the denominator. Next, find vertical asymptotes. Finding vertical asymptotes is very much related to the previous problem, except it's the same, but you do not count any terms that are canceled out. For instance, here, x minus 2 cancels out, leaving me with only x minus 3 does not equal 0, or equal 0 in this case. And so when I solve plus 3, x equals 3 would be the vertical asymptote of that function. Horizontal asymptotes, there are a set of rules that I posted when we did this lesson, but I'll just say it really briefly. When you do this, all you look at is the first term of each, the highest degree term. So I'm really just looking at 4x squared and 5x squared. And then over here, I'm going to look at the following: 3x squared and 2x to the fourth. There are two main options. One, if they are the same, like they are here, x squared and x squared, if the degrees are the same, then I just simply say that y equals 4 over 5. Notice all I've done is taken the coefficients. Now, if they are different, you have one or two options. If the denominator is larger, like this x to the 4 is larger, the answer is immediately y equals 0, and that's it. If it's any other option, then you do not have a horizontal asymptote. So either the degrees are the same, or the bottom degree is larger, and these are the two outcomes there. And that is all summarized in the notes as well. All right. Let's look at our exponent and radical function stuff. First things first, it talks about changing between exponent and radical form. Remember, it's simply that the top number is the root and the bottom number, or sorry, other way around. Made a mistake there. Sorry about that. Top number is the power. The bottom number is the root. So this would become the fifth root of x squared. And then on the other side of this, since this is already in root form, we would convert this into b is equal to 7 over 3 power, with, again, the top number coming from the root, or the power, and the bottom number coming from the root. All right. Down here, doing some simplifying. They just really, you can use your calculator for some of this, like this first problem, but we know that if we do 4 squared to the third, we're going to multiply those. So it's going to be 4 to the 6th power, and then I'm going to type that into the calculator. And you could have just done 4 squared and then do the answer to the third power, either way. But if we remember the exponent rules, we remember that we multiply those two. So we're going to do 4 to the 6th power. Pretty big, 4,096 on that one. Looking at this next one, this is slightly different. And we're going to distribute, in a sense, this 1/3, which means it's going to look like this: 27 to the 1/3, x to the 9 over 3, because 9 times 1/3 is 9 over 3, and then y to the 12 over 3. 27 to the 1/3, you can use a calculator for that, but you'll get the answer of 3. X to the 9 over 3 makes x to the third. 9 divided by 3 is 3. And then 12 divided by 3 is y to the fourth. And that's pretty much it. More of the same on the following problem down here. We're going to distribute this 12 to both of these. So it's going to be b to the 12 over 6 and c to the 12 over 4 when we multiply those fractions, giving me b squared c to the third. And that is it for that page. Let's move on to our next section where we have compositions of functions. So remember, compositions are when you plug one function into another. So make sure you go back and watch that video because it's a pretty important concept. But we need to convert everything into exponents if it isn't already. So like f of x we want to write as x to the negative 3. This is going to become x to the negative 2. And that just makes it a little bit easier to work with when you're doing this. And then we'll deal with that last one separately. But in this first problem, x to the fourth and x to the 1/2, if I do g of x, it means I'm going to take this entire thing and I'm going to plug it in where the x is here. So it's going to look like this. X to the 1/2 to the fourth, which results in x to the 4/2, which is the same as x squared. Pretty straightforward. All right, same. Next problem, I made a mistake there. This should be a 2. But again, I'm plugging g into x. So I'm going to take this function here. I'm going to plug it into the x here. So it's going to look like this, parentheses, x minus 2 to the negative 3 power. I multiply those numbers, giving me x to the 6th. Lastly, I'm taking this g, I'm plugging it over here for this x, and we get 3 parentheses square root of x squared minus 1. We know that the square root of x squared, that's going to cancel out completely. Use a different color there. That's going to cancel this out completely, giving me 3x minus 1, and that is the final answer there. All right, last one, I believe, is, yes, find the inverse of functions. So to find the inverse, we have to switch this so that it becomes the y equals version of this formula. So y equals x minus 3 to the 1/2 power. We switch the x and the y terms. X equals y minus 3 to the 1/2. I'm actually going to move that so I have room to work. Move this up here. Sorry about that. In fact, let me just rewrite this again. All right. I end up with y equal, or x equals, sorry about that, x equals y minus 3 to the 1/2. Now I need to solve for y. So I'm going to raise everything to the second power. That's going to get rid of the 1/2 power. That's going to cancel that out. So this is going to become x squared equals y minus 3. Then I'm going to add 3 to both sides, and that is it. Y equals x squared plus 3. And there we go. Next one, again, same idea. Rewrite this as y equals x to the 1/3 plus 5. We're going to switch the x and the y like we've been doing. We're going to switch these. It's going to end up being x equals y to the 1/3 plus 5. And we're going to start solving. So when we do that, we subtract 5 from both sides. X minus 5 equals y to the 1/3. To get rid of that 1/3, we need to raise this entire thing to 3. We'll do that to both sides to cancel that out, giving me y equals x minus 5 to the 3rd power. And that is it. All right. So I do want to go back and look at one other thing. Oh, no, it's not on here. But what you need to also study, if you look at the study guide, make sure you look at the bottom where there are 3 vocab kind of reminders of things that you need to look at. So that's kind of a summary of everything you need to know how to do. You need to go back and look at previous lessons if you need help with those individual items, or you can reach out to me to have some time to go over things before you take the test. That is it for Algebra 2, Unit 7 review.